Hello, Gary Parker here. I'm going to do a little overview of Intermediate Algebra Math 95, Week 2. So let's check it out. So a couple things to remember. Daily work schedule shows what you should be working on each day. So today, Tuesday, the 16th of January 2018, you should be working on section 1.4. 1.3 should be done, as should be 1.1 and 1.2. There's going to be due date reminders here, so although you should be trying to finish 1.4 today, it's due tomorrow. I put a note on testing, which is related to a note that appeared when you logged into Canvas last week about how to do tests for this course. So check that out. If you have any questions, get in touch with me. Check out Module 1. So end of last week, beginning of this week, you were finishing up special products. I'll take a look at that in a moment, along with reviewing section 2, and then an overview of section 4, and then a little bit on chapter 2, 2.1 and 2.2. So the big thing is factoring from chapter 1. Chapter 2 is going to jump us into an idea called functions. So let's take a look at factoring first. If I can get my pen to work. Oh, we're going now. So when I have a polynomial like this, I can hope that it factors into two binomials. So I'm going to demonstrate what's called factor by guessing here. What was multiplied to give me an x squared? Well, that was likely x times x. To give me 15. That's a little trickier. That could be 1 times 15. That could be 3 times 5. And 4 doesn't go into it. I get to 5. I have a repeat. So these are all the combinations. And so I need a combination that's going to somehow add or subtract between 2 in the middle. Since this is really a negative 15, that means these guys have to be opposite in sign, which means I need to subtract them. So I would guess it's 3 minus 5. This tells me the 5 has to be negative to get a negative 2. So I can come over here and put a plus 3 and a minus 5. So I believe that's the answer. It's an educated guess I just made, but I don't really know for sure until I check to multiply it out. So although on your homework you have that submit your answer and it will tell you whether you're right or wrong, on the test you don't have that. And so you want to know on your own before you hit submit whether it's correct or not. So you should always check. So to check, I just have to distribute this back out. So x times x is x squared. X times negative 5 is negative 5x. 3 times x is plus 3x. And positive 3 times negative 5 is negative 15. The only like terms are the two middle ones. If I lose 5x's and gain 3x's altogether, that's a net of losing 2x's. Minus 15 is hanging out on the edge. X squared is right. Since x squared is a different kind of object than 2x, this is like a floor tile, a square, versus a piece of string, a length, x. And this is just 15. These aren't like I can't take it any farther, but it does match what I started with. So I have confirmed that, yeah, this is indeed the answer right here. I factored x squared minus 2x minus 15. Other things from last week and the beginning of this week are the idea of special formulas. So for example, if you had something like 4x squared minus 9, you could notice that 4x squared is a perfect square. It's the square of 2x. So 2x times 2x. And 9, it's a perfect square also. It's the square of 3. So this fits the difference of two squares formula, which says it'll factor as a binomial times a binomial. One of the binomials is 2x minus 3. The other would be 2x plus 3. And so if you remember that formula, that's a quick way to get the factored form. The other thing we're going to look at this week is how to factor more complicated things and the idea of a function. So you're going to see function notation, things like f of x equals 2x plus 6. And what does that mean to write an f of x like that? So we'll get to that at the end of this video. So the formulas that you need to commit to memory, most important formulas, this one would be number 1, these guys here, number 2, and these guys here, priority on number 3. We'll review these again in a later chapter. The other ones you just have to know. So let's try so I just applied on the previous page the difference of two squares formula right here. So next I'm going to apply the sum of two cubes. So here's the formula. So it's a matter of recognizing when things look like that. Then you can apply the formula to try and rewrite it in factored form. And remember, factor just means write as a product. So here's my product between the two parentheses. So suppose we had 8y raised to the third plus 125. So I see there's two terms, and I see a y cubed. So next I hope the 8 is the cube of something, and 125 is the cube of something. So then guess and check on your calculator. So my guess is that 8 is the cube of 2. So if I take 2y, and then I cube it, 2y times 2y times 2y, that should give me 8y cubed. Guessing at 125, if you take 5 times 5 times 5, yes, you will get 125. So in this case, I think my A for the formula above is 2y, and I think my B is 5. So applying the formula, it says I should get a factor of a plus b, so that's just 2y plus 5. Then I need an a squared, so what's 2y times 2y? That'd be 4y squared. Then I got to get a minus in there right away. 2y times 5 would be 10y. Right? A times b, and then finally b squared. 5 times 5 is 25. So I challenge you to multiply this out to check that it is indeed the factored form of 8y cubed plus 125y. So please check that on your own. Something else to think about, could 4y squared minus 10y plus 25 be factored further? So we'll look at that in a couple of slides from here. So section 4 is about factoring things completely, and the main tool there is what's called the AC method. With the AC method, have something that looks like this, something a times x squared plus something b times x plus some other number c. I kind of have that right here, a cube, a square, and an x. So an important first step always with factoring is there a greatest common factor, something that every term has in common? And look at these terms. I see a couple things. I see they each have at least one x to give up, so I can factor out an x. But I also see that each of these is even. So I should be able to factor out a 2. And then I look at what's left behind if I remove a 2x from each of these. If I do that, 2 goes into 12, leaving a 6. X goes into x cubed, leaving x squared. Minus 2 goes into 22 11 times. X goes into x squared, leaving an x. 2 goes into 8 4 times. X divided by x is 1. 1 times 4 is 4, so that's the factored form. So I've made a step toward factoring this, right? I've written it as a product. Next question, does 6x squared minus 11x plus 4 factor? And here's where the AC method comes in. AC method means take A, the leading coefficient, multiply it by C, the trailing coefficient here. So positive 6 times positive 4, that's a positive 24. So off to the side here, I'm going to write that my AC is 24. Then I want to factor 24 in as many possible ways as I can. So it could be 1 times 24. 2 goes into 24 12 times. Calculator would be a good idea. 3 goes into 24 8 times. Or on your homework, challenge yourself to remember those facts, do them in your head. On a test, on some tests you can use a calculator. Double check with your calculator. 4 goes in there 6 times, 5 doesn't go in, and then 6 would be next, and I already have 6 right here, so I'm done looking for factors. Next thing I want to do is think about whether I add or subtract these. Since that's a positive 24, I want to add these. Again, because the 24 is positive. So what combination will give me an 11? Well, 3 plus 8 is 11. However, I don't want just an 11, I want a negative 11. So that means these should both be negative to give me a negative 11. Double checking, if you take negative 3 times negative 8, negative times a negative is a positive 24. So it still works out. Once you find the magic pair that multiplies to give you the AC number and adds or subtracts to give you the middle term, then you replace the middle term with this magic combination. So I'm going to replace negative 11x with a minus 3x minus 8x. Right? So plus a negative is the same thing as minus. And again, the minus 3x minus 8x, that's where the negative 11x comes from, is my hypothesis over here. Bring in the first term, 6x squared, and the last term plus 4. Once you break it into 4 terms using the AC factors, then you factor in pairs. So look at the first pair, 6x squared minus 3x. Do these 2 terms have something in common? Yes, they have a 3x in common. And if you factor the 3x from those 2 terms, what does that leave behind? Let's see, well, 3x goes into 6x squared, leaving 2x behind, minus 3x goes into 3x, the number goes into itself once, leaving a 1. Moving on to the next part, what can I factor from the next pair? Now that next pair, that negative is really part of the 8, so that has to be factored out first. And then otherwise, these guys have a 4 in common. So that means I have to factor a negative 4 and see what's left behind. This is a tricky part. So negative 4 goes into negative 8, positive 2 times, and the x is still left. And then negative 4 goes into positive 4, negative 1 times. Right? Because other way around, negative 4 times negative 1 is positive 4. Always double check all your signs in both parts. So the factor by grouping, which is what I'm doing here, that's a success if the binomial that's left behind each time is the same. So check, I got that. If it is the same, pull it out. So I want to factor out that 2x minus 1, that common binomial. Once you factor that common binomial out, make a note of what's left. There's a 3x minus 4 left. That must be the other factor. Close parentheses. Now let's not forget that we factored a 2x in the beginning. So I think the completely factored form of 12x cubed minus 22x squared plus 8x is this right here. And you can check that by multiplying. So to check this, we would first multiply 2x by 2x minus 1, and take that new binomial and multiply that by 3x minus 4. So a lot of times students aren't in the habit of checking the work on their homework. Get into the habit of doing that before you hit that submit button. Check this out. I'm going to leave that for you to review stuff from last quarter. So check by multiplying. You really want to do that on the test for sure. That way you can ensure you're doing things right. If it doesn't check out, then just try again on a new sheet of paper. All right, let's try another one. So I said I would come back to the trinomial that was left over here, the second part from the sum of 2 squares. So I want to see if this factors using the AC method. So the first step in the AC method, excuse the background noise, is to see if there's a common factor. Is there something common to all 3 terms? And the answer is no, there's not. So then I go straight to the AC method. 4 times 25 is 100. That's my AC. Factor 100 as pairs in as many ways as possible. So 1 times 100, 2 goes in there 50 times. Let's see, 3 doesn't go in. 4 goes in 25 times. 5 goes in 20 times. 6 doesn't go in since 3 didn't. 7 does not go in if you check on a calculator or do division. 8 does not go in. 9 does not go in. 10 does, 10 times. And now I have a repeat, so I'm done. That's my list. Now, this is a positive number, which means I want to add these factors to try and get the middle number 10. Well, the smallest sum I can get is 10 plus 10, which is 20. Above that, it's 5 plus 20 is 25, 29, 52, and 101. All of these add up to be a different number than 10. Now, you could get desperate and try and subtract them, but none of them subtract to be 10 either. None of the possible combinations from the AC method work. No answer here. That matches the 10, so that means this is not factorable. It doesn't factor any further. And most of the time, the result of using that cubic formula, it won't be factorable. 9.9% of the time. All right, so that's most of the overview of chapter 1. Let's take a quick look at chapter 2. In chapter 2, we're going to explore the idea of what is a function. So the idea with a function is this equation. You've seen this before in a previous math course. It's a linear equation. It's set up so that you can plug in x to calculate y. So for example, I could say, let's let x equal -2. Then y would have to be 2 times -2, or we use parentheses when you substitute in, plus 6. Order of operations, multiplication first, that gives me a -4 plus 6, which gives me a +2. So if x is -2, then y equals +2. Now, what it means to be a function is that you have something, a formula where you can plug in on one side, and you get a value for another number on the other side. So that's part 1 of being a function. Part 2 of being a function is that we all agree on a single answer. Okay, so this is fundamental rule of functions. So if you're given an input value, right, that's right, plug in x, then there should be no more than one output value. And that is the fundamental rule of being a function. Okay? So this is true. So I think we'll agree that no matter what x value we pick, you and I will do the calculation and we'll agree on the y value. So if I said x was 1, I hope we agree that y would be 8. Okay? If I said x was 100, I hope we would agree that y would have to be 206, and so on. So if that's the case, then we can say that, yeah, y is a function of x. It just means it satisfies this fundamental rule here. Now, that's a lot of words for math, and so math people like to abbreviate things. So to abbreviate that sentence, y is a function of x, we would say y is a function of x. And so instead of writing y equals 2x plus 6, since y and f of x, y is a function of x, mean the same thing, we could instead, and you'll see this a lot now, you'll see things like f of x equals 2x plus 6. So all that means is f of x is a y value. And that when you plug in an x value, you get a unique answer, if you get an answer at all. Sometimes you don't get an answer. We'll look at that later. So for example, if I wrote something like f of 3, the translation of that means x equals 3, oops, x equals 3, right? Because I wrote that instead of the x. What is y? So function notation allows us to say a lot with just a little bit of symbols. So then I would do the calculation. F of 3 would be 2 times 3 plus 6. 3 times 3 is 6, plus 6 would be 12. So that means y is 12 in this case. Okay. So this right here translates as this right here. So it's a shorthand. Okay. So we're going to spend some time getting used to functions. Just some other terminology. X, our input variable, is also known as the dependent variable. Sorry, independent. Independent. Because we can pick any x value we want. And then the y value depends on which x we pick. So our output over here, the y, that's our dependent variable. Let's see independent and dependent come up. All of the x values that you get to play with, your independent variable numbers, that's called the domain. Domain is all of your x values. All of the values the dependent variable gets to be, like the 12 I got here, like the 2 I got on this page right here, those are called the range of the function. You'll also see range come up in this chapter. And range just means what are all the y values you end up with. I'll come back with more on domain and range. There's a whole bunch in the videos already in the course. I just wanted to give you an overview of what happened last week and what's going to happen this week. Enjoy, do good math, stay in touch. Bye-bye.